The presentation is focused on design of combination logic circuits. The design steps for combination logic circuits involves there is 5 steps: specification, formulation, optimization, technology mapping, and verifications. These design steps can be explained with the help of BCD to XS3 code converters. The BCD is a code for decimal digit 0 to 9, and XS3 is also a code for decimal digits. This is the decimal digit up to 0 to 9. This is the input BCD. BCD stands for binary coded decimal. Then this is the output. We are going to get the XS3 output. These binary digits we call it as a weight based binary codes. Each digit have some weights. These digits have most significant bit have weights of 8. These digits have 4, and these digits have 2, and this one is 1. Each digits have corresponding weights. This is 8, 4, 2, 1 code. This here we are giving input 0. We are going to get output as 3. We are adding 3 to these binary digits. This is the 0. Here we are getting 3. Here are 1. We get a 4. Likewise, we are going to get 9. We are giving input. This one we get an output of 12. Okay, the specification of BCD to XS3. Here this is the inputs. We are giving BCD input A, B, C, D, with A is the most significant bit and D as the least significant bit. Output and XS3 output is W, X, Y, Z that correspond to the BCD input. The internal operations we are using logic gates to design, and we get the convention in combination logic circuits. Then formulation of BCD to XS3. XS3 code is easily formed by adding a binary 3 to the binary or BCD for the both BCD to XS3. Formulation of BCD to XS3. The XS3 code is easily formed by adding a binary 3 to the binary or BCD for the digit. There are 16 possible inputs for both BCD and XS3. It can be assumed that only valid BCD bits inputs will appear, so the 6 combination not used can be treated as don't cares. This is a corner map techniques, or we can call it as a K-map. Where are the minterms located on a K-map? Here this is a K-map. This is a 4 variable map. These corner maps are used to minimizing the variable functions. So here this is A. This first digit represents A and this second digit represents B. After getting the formulations, we are using K-map or corner map techniques for minimizing the Boolean expressions. This is the K-map method. This is the 4 variable map. This is this 2 AB is the input variable, CD is the input variable. This AB we can represent here, and then CD we can represent this likewise. Here this first digit represents A and second one is B, and likewise this represents C and second digit represents D. This is the here you can see that the second, third and fourth columns is being interchanged, and likewise the third and fourth row is also interchanged. Now we are using that inputs we are going to plot into that map to reducing the Boolean expressions. This is the layout for K-maps for each output W, X, Y, Z. This is the XS3 output. Here it is the output for W, and this is the output value for X. This one value represents that what we are getting, that output value 1 in the tables. Okay, likewise these methods we can going to group that individual mappings. Here we are using this don't care for after this BCD is over. The binary coded decimals up to 9, the remaining 10, 11, 12, 13, 14 and 15 is used as don't care. This represented in X. Then this is for W minimizations. Here we are going to group that in corner map method we are going to group maximum possible number of. So we are grouping this 8 possible numbers, so we get A. Then second one we are going to group this 4. Here in corner map method we can group up to the power of 2 power n only. We can group single or 2, 4, 8, 16, 32 likewise. Now we are going to group this 4. We can get BC, and we are going to group this 1 4. We can get BD. For while grouping like this, these 4 columns has been eliminated. Here this is for a different value, so this can be eliminated, and this is going to be get it A. So like this we are going to plot A. Same things here we are going to these factors, 2 columns are involved, same way these 2 rows are involved. So consider these 2 rows. this one is common, so we can take it B, and here this second that is common, so we can get C, like as C. So like as we are grouping that W minimizations, output W, then X, then Y, then Z. After this grouping we find some value. This is a Boolean expression what we are getting after grouping that in corner map. So here we see that B is common, so we take it as a B common, then we get a final expression A plus B into C plus D, like this. Likewise we are grouping here B dash is common, C plus D. So after this getting expression here C plus D represents, so we subtracting out C plus D and call it T. So T dash equal to C plus D dash, so we get C dash into D dash. So finally we minimize that Boolean expression into simplified form. So we are going to implementing these functions in using logic gates. Here we can using that implementing this. This is A, B, C, D input. We are giving binary input. Here we are getting a XS3 output W, X, Y, Z. These logic expressions can be implemented using logic gates. Likewise. So implementing that T equal to C plus D, here we are using C plus D adding this. So simplifiedly we can use the common expression T to the W and Y. So thank you for your patience and kind attention. Thank you.